Welcome everybody. This is taper 101. So make sure you are in the correct room. Where have the speaker, Roozbeh Davari from the Honest Company. Roozbeh Davari is a data scientist at the Honest Company and works on optimizing revenue drivers. For example, the digital marketing, and improving the UX and building services for various stakeholders. Previously, he worked on credit model for fintech, startup, payoff, etc. He received a PhD in astrophysics with a focus on galaxy in evolution and joined the Inside Data Science Fellow Program before starting his career in data science. He will presenting a talk titled Using Machine Learning to Optimize Marketing ROI at Honest Company. Please join me in welcoming Roozbeh.
All right. All right, good morning, everybody. Good morning. It's good to be here. Thanks for coming, and thanks to the organizer. This is my third year at Big Data Day LA, and it's amazing how much we've grown. And I think the first conference I went to, the room was at least 5 times smaller than this, and there were less tracks too. So it's great. And this morning I was thinking about my first conference, and at the time I was aspiring data scientist, for those of you out there. And I was overwhelmed with everything that everybody was talking about. I was like, I will never be able to understand what these people are doing. And it turns out that in a couple of days we can learn a lot and even give a talk. We'll see how this turns out, but still. All right, so I'm here to just tell you a little bit about how we basically use data at the Honest Company. And we work with different stakeholders in the company, and I'll get into details of how we do that. So for those of you who haven't heard about the Honest Company, we are a mission-driven company, and our mission simply is to just empower people to lead a healthy, happy life. And we have been around since 2012. We have by now over 100 products in different verticals. We started with diapers and wipes, and later we introduced cleaning products, personal care, and a major addition to our vertical has been Honest Beauty in the last 2 years ago, and we're still growing. And we offer subscriptions for all of this, so we rely on our subscription model. And that's the thing that you need to remember about this subscription. I'm going to come back to that. All right, so this is the type of slides that you either have seen so many times, and if not, don't worry, you'll see it a lot today. But the reason I put it up here is to just say something that I really like about working at Honest, and that's the fact that we have a great data engineering team, and we work very closely with them, so we get the chance to get involved in all the stages here. So we get a ton of data. We sometimes set the requirement for data, how it's pulled, how it's surfaced, and how it's pre-processed. And of course, we spend a lot of time here, visual engineering, exploratory analysis, building model, making predictions. And one of the funnest part is that we get the chance to work with the stakeholders directly within the company, which is really fun because you get a sense of what's going on in the business, and at least to me, it makes me feel better about what I've done there. All right. So the data science team at the Honest Company is called Solution Team, and we serve many different ways for different purposes. But there is a main theme in there, which is helping with growth and retention, and it has different ways. There are different ways of doing that, and we use different approaches to do that. Like sometimes it's statistical analysis, sometimes it's just visualization or pulling data. But the one that we're going to focus on today, of course, is going to be machine learning and how we've used it for a couple of applications within the company. When I think of machine learning, so there is some familiar examples. Like we built the recommendation service there, or search service on our website. So we provide an API for different teams to use it, and then it improves the UX, user experience. The other one is that I'm sure you have seen a lot, is that you build a model, there's an output number, people use that to make a decision. But another aspect that is really important is machine learning is going to help you understand what is really leading to this success or failure in your business. It can be used for gaining insight in the drivers of, for example, revenue or increase in conversion rate. So I'm just going to focus on 3 models today. And I think these go together. And also it's relevant to a lot of businesses, especially if there's some sort of subscription or recurring purchases. So the first one is churn model. So churn model is basically going to give you an idea of users that are at risk of leaving you, or on the other end, your loyal customer, the one that you know that are going to stay with you. And it goes, it ties closely with conversion model. So we offer trials, like a lot of subscription models. Like Netflix, you get a 1 month of free subscription, and then it turns into, for the 1 month of free trial, and then it turns into subscription. The same happens with our model. So we have a model that helps us to predict which user if they're going to convert or not. So going back to the third point that I made about machine learning model, we use this a lot to understand the ups and downs in the rates, either for churn rate or conversion rate, and those are really, really important. It can be used for marketing, for example, optimization, understanding the customers that are coming in. Is a product that we thought we're going to perform in a specific way, are they performing that way or not? So they're very important, those insights that you get from machine learning. And finally, for the rest of the talk, I'm just going to focus on this actually. It's LTV model, which to me is a more holistic model. It includes churn and conversion. And on top of that, adds another component, which is the dollar value. And for those of you who haven't heard the term LTV or CLTV, it's basically getting a sense of how much a customer is going to spend with you during their lifetime. All right. So it's a big conference, so I assume there's a diverse background. So I wanted the first half to be high level, how data science can be helpful to the business. So the second half is going to get more technical, and it's going to be a little bit more juicy. And hopefully for people that are a little bit more experienced, they find something useful in it. So I'm going to focus on 2 variations of LTV model that we use. One is for subscribers, and one is for new users. The main difference is that for subscribers, they've been with us for 1 month, 2 months, 2 years, 5 years, and we have a lot of data on them. So the problem is a little bit more trivial. For a new user, you just walk in the door, you're trying to figure out how much potential you're going to spend with us. So it's more challenging, and we have to get a little bit more creative. And all right, let's jump into it. So going back to the slide that I showed earlier. So we have, as I said, different verticals, or different subscriptions, or different bundles, we call them. And they're going to attract different audiences, right? So for diaper bundle, if you have a kid, you need diapers and wipes. Every 4 or 5 weeks, you need a specific number of wipes. And so the order frequency is going to be not going to have a lot of variation, right? But at the same time, there's a cap to the lifetime. So after 2 or 3 years, you don't need it unless you have another kid. For something for beauty, different customers are going to have different behaviors. Somebody's going to order every 2 weeks. Some people are going to order every 4 months, right? And at the same time, the lifetime, there is no end to it. They can stay with you for decades. So the reason I'm telling you this is that a very important factor for those of you who have built LTV models know that is recency and frequency, like how many times they've ordered, what was the last time they ordered. And you want to capture that in the best way possible. And for different bundle type that we have, we're going to be different stories. So I'm going to tell you how we've done that. So this is a setup for our subscriber LTV model. It's very typical, right? You have some features, We have hundreds of features. We go through feature selection and everything, feature engineering, and then we fit them in a final model. But the part I'm going to focus on is this piece, which is Pareto MBD model. And it's a model that has a really nice implementation in Python and R, by the way, that helps you to capture that frequency and recency really nicely. By the way, how many of you have heard about Pareto and MBD? All right, about 10 people. And good, so it's going to be new for most of you. So the idea, so when you go through the paper, it may seem like very overwhelming, the math and everything behind it, but it's actually a very intuitive idea. And just putting some intuitive distribution together, you can get a really powerful model. So for something like subscription, you're going to have frequency of orders. So each user is going to get a distribution for their order frequency. So it's a rate, and there's a period. So therefore, the distribution should be something like Poisson, right? So we get a Poisson distribution for each user. And then you need a churn function. You want to know how long the user is going to stay with you besides the order frequency that you're going to have in each period. And you can imagine the user is going to join you, and they're eventually going to leave you, right, over time. So exponential is a very intuitive choice for that. So that's it. Each user gets two distribution based on their order history, a Poisson, exponential. But I think the powerful part that comes in for Pareto MBD model is that not only it looks at each user, but it looks at the whole population. And by that, I mean, it looks at all the people who buy diaper bundle, and it puts some constraint on the, for example, rate parameter for a Poisson distribution. And how it does that is it uses maximum likelihood, fit a gamma function, which is a prior distribution that you can drive parameters for different distribution. And out of that, you get individualized function for users. All right, so to just wrap it up, so it looks at each individual, the whole population, and builds a prior, so that this is the distribution of different parameters for all my users. And look at the user's purchase history, which is going to be your observation. So combine prior with observation and gets a posterior for a user, which is an analytical function. And it's amazing because it gives you a lot of information. For example, it tells you what is the probability of user being alive in the next 6 months, and then in a year, in 2 years, in 10 days. It depends on how you set up the model. And what is going to be the average number of orders they place, or the total number of orders they're going to place. And it's one of our strongest features. So another thing that you may have not seen it is that you can use a model, build a feature, and use that feature as an input for a final model. And it's going to be, at times, really powerful. And so that's what we've done here. To give you a sense of why you need to tie frequency and recency together, because some people just use recency and frequency directly in a model. But tying them together is really important. Here's an example that hopefully will give you intuition. So we start observing the user, let's say, at some point here. And that user has a probability of alive, which is opposite to churn. So the user has a probability of alive. They don't place an order, so their probability of alive drops. So that's the recency factor. The more there is a distance between your last purchase and present time, the probability of you being still active is lower. But once they place an order, the probability jumps up. Good, the user is active. And again, it drops between orders. But you notice what's happening. Between orders, the rate of drop is dropping. Right? It drops slower. So the frequency of orders is affecting how the recency is affecting the lifetime of the user, or the churn function of the user. All right. So that's subscriber LTV. So we had a lot of data, we had recency and frequency, and there is a powerful method out there, Pareto MBD, that you can use to capture that frequency and recency for each user and build an analytical function. Now I'm going to shift gear to new user LTV. So again, for a new user, they just walked in, placed an order, and you're trying to predict the dollar value for them, for their lifetime. it's challenging again because there's not a lot of data. So we started by looking at the data. So this is like an LTV distribution. So basically this is a histogram and this is increasing LTV this way. And we wanted dollar value, so of course like the way you want to go around, about it is just use regression. So we use regression. Again, we have hundreds of features. We go through L1, we do some model selection, reduce features, and then we use something like that uses panelizing the features. You have the option of using L2 or ElasticNet, which you basically want to make sure that you don't have overfitting in your model or too much variation. So we did all of that, and we did a regression model, and it was pretty disappointing. So our R-square was really low. It's decent, but it's not really at the level that we were comfortable putting it in production. But besides that, so when you run a model, there are some important assumptions that you make or some conditions that need to be satisfied. Otherwise, your model is not valid. For a linear model, one of them is heteroscedasticity. And basically what it says is that there should be the way it manifests is that there are some patterns in your residual of the model. So you look at the noise and you see some pattern. And it's a problem because when you use a linear model, you assume that, hey, there is a linear relation there. And there's some unexplained variation that you cannot explain, right? Irreducible error. But there's no pattern there. It's random. But we noticed that it's not. So a linear model was not a good option. So we went after using a tree-based model, which is a natural choice, right? Tree-based model regression is available, and so we went after that, and that's actually what we got to 0.35 at the higher end. And it was not good. And the regression-based, tree-based regression models have their own limitations too. For example, the prediction is going to be always limited to the same parameter space that you gave it. Like if, for example, your LTV range that was in the training model was between $1 to 100, your prediction always going to be in that range. That may not be realistic. All right, so then we got creative. So if you look at this, you see that there's a huge peak here, and these are people who are not going to place any order after. So they came in, placed an order, they stayed there. We thought if we can turn this into a binary problem, let's just identify those and separate them from the rest of the population. We already have done a lot of work. And we did that, and it was pretty good. So we used XGBoost, some powerful classification machine learning algorithm, and AUC of 0.85. Great. It's like, okay, so let's turn this into a hierarchical model. Let's first run a model, identify these people, put them aside, and believe that we did a really good job. And let's go after the rest of the population and see if we can do something about them. So we did. So after removing that peak, this is what is left behind. This was already there. You couldn't see it because of the way the bins were set up. And I wanted to have like a surprise element for you guys too. So, so when you look at this, right away you can think of it as a multi-class problem, right? You see different peaks. And it actually goes back to what I mentioned at the beginning. We have different type of subscription. They're going to have different prices, right? When people come in, you expect to see these different peaks. All right, so we turned this into a multi-class problem. And actually, again, the performance was good. We were happy about it. And we were like, great. Okay, so we have a binary class, which is good, a multi-class, which is good. But there's still the problem that we had at the beginning. We want a dollar value. Right? How do you go from that to have a dollar value per user? And the method we tried to use was bootstrapping. You can just do sample. So, we have a good amount of data that we thought we have a sample that is representative of population at a good level. And let's just go and use those classes and do bootstrapping. And by that, what I mean is that you get a vector when you do a multi-class prediction. right? And one of them is going to be dominant, and you can say that that's your prediction, right? For example, here, class 3 is going to be the class with the highest probability. So you can just go to back to your population in that class and just do a bootstrap and get whatever you want. You can do mean or median. And besides getting a value, you're going to get a sense of uncertainty in your model. Or something that is going to give you a more realistic distribution of both prediction and error is just use the whole vector, right? Use it as a weighted sampling, and for example, get 10% of your sample from here, 80% from here, and combine all of them, do a sampling, and then do bootstrapping on top of that. So again, the distribution is going to be wider. You expect that. It's more realistic. But at the same time, there's going to be more variation in your mean predictions or median predictions, which is more realistic too. All right. Oh, good. Okay. To just wrap it up, so again, at the Honest Company, we have a lot of a ton of data, and we do machine learning, use machine learning, statistical analysis quite often, and we work with different teams within the company, and we focus a lot in improving UX. And then I touched on two hopefully interesting application of machine learning. One is that we can use a model and build features out of that and use it in a final model. And the other one is that sometimes you need to do statistical analysis on top of the output that you get from your machine learning model. So sometimes machine learning model prediction is not your last step. And doing some work after that is going to improve your model or performance. All right, thank you guys. All right, any questions? Yes. What I mean.
So when you came up with your scores,
so after you got your scores,
Right.
what would be a practical way to validate whether the business is seeing those impacts? If you come up with 0.85, is it because the sales cycles are pretty long? In your case,
So when you say the scores, you mean like when you get the vector from the multiclass?
Right. So if you get a lifetime value,
Right.
you know whether the algorithm really did.
So I think that's going to go back to your validation, right? How you validate your model. And in validation, there's some specific metric that you can use, like accuracy for your multi-class, or just focus on each class and go after that. Like, for example, turn it to binary and do recall. There's one aspect of it there. And then there's another part that business comes in, right? So business, most likely some classes are more important than others, right? Like, your business may care about identifying people who are actually going to have very high LTV, and you want to make sure that you're doing a good job there, right? So we did those type of validation, both on the modeling side and the business side, and it was doing pretty well. Yeah, go ahead. I can repeat the question. Here.
So in one of the slides earlier, you showed that the R-squared regression value was a little bit low. So what is typically the standard or minimum standard that you guys use at Honest to see what is actually a good fit for the model?
Right. That's a tricky question. I don't know if we have a number that we're like hitting that we're like, yeah, we like hit that number. But I would say below 0.5, it's a little dicey if you want to like use it heavily. It also depends how you're going to use it. So there are problems that I did not expect to have a higher square. I just wanted to know if there is an effect, right? And I was happy with 0.2, 0.3, and like, wow, I didn't expect even this. But if you want to build a prediction that you're going to use daily in a different aspect of your business, you want to have something that's like 0.5, which, did I answer your question?
Yeah, thank you.
Okay. There are questions.
Hi, my question is,
Thank you. Hi, my question is, so we saw a lot of analysis being done and a lot of insights getting generated. So from a business perspective, what would be the ideal rate at which you would want all of this put into action? Like how frequent on a monthly business cycle?
I'm not sure if I got the question. So you're asking how the model are used for business?
No, like if I was let's say running the recommendations or managing sales, like how frequently would you want the business manager to be executing recommendations?
How often do I want the manager to execute or take action based on this model?
Yes. Yeah.
Oh, I want them to do that all the time. And it happens. Like we have models that are used daily, and we have services that are used every second. Like we build I work on the recommendation engine, right? Mm-hmm. Every time you go to a website, you're using something that we contributed to. Or every time you do a search on the website, you're contributing to that. So there are APIs like that is like all the time there. Then there's model like this that they get used at least daily. And then there are analysis that it takes 6 months. And it's at the end, it's just a few numbers, right? So it really varies on what the application is. But for me, I want to use it all the time.
Got it. But does that mean that operationally you guys are able to execute it at the frequency you want?
Oh yeah. Okay. Yeah, we have a very efficient pipeline of like going from pulling data to like putting something in production very fast.
All right. Thank you.
Yeah.
Hi. So you talked about Pareto and BD models.
Right.
Yeah. So is there a specific reason you choose that? Like why not survival models, or there are different ways of computing LTV?
So in survival models, you can use that too, right? But also you're making some. It's very similar. You're making some assumptions on how people are going to behave, right? And you can split that again between your bundles and do that. But there you're not going to get, and for the churn perspective is really good, right? But there you don't get the expected number of purchases there, right? So in other words, the problem there is churn compared to LTV. Does that make sense? In survival model, you don't get it like a function for this user is gonna, this is the probability of user placing an order with this specific count, right? Which is your Poisson distribution. But you get that exponential power, which is really powerful still. And we use that for our churn models.
So you don't you don't compute your churn probabilities over the period of time and then can compute dollar value out of them, like.
So the Pareto takes care of that.
Okay.
For you, yeah, that's a nice thing. It makes your life really easy.
Here.
There's a question right in front.
So after you went from binary class to multi-class and to bootstrapping to find out people's lifetime value, right? What business decision did these output actually drive? And you mentioned about membership bundles, right? But I'm not too clear as to like what business decisions did your results actually drove.
Well, there is a reason it's not clear because there's so much I can discuss. But let's say that. So once, let me give you a high-level application, and that's when you have different efforts for driving revenue, right? It can be different things: TV, coupon, digital marketing, right? Facebook, whatever, Google, and they have different costs associated with them. Right? It costs you this much to bring a customer in, for example, right? You want to know if it's worth it or not. How do you do that? Does that make sense? Okay.
This will be the last question.
Go ahead. I'll be around after too.
Two separate LTV models for the marketing channel.
The question is that do we have different LTV models for our marketing channels? I cannot answer that directly, but that's a good idea. Yeah. Yes. Go ahead.
You talked about how you have models in production, like in the form of APIs. So
Right.
Could you talk about like how do you make it near real time prediction? Like what kind of tools or methods do you use to make it more like a in production?
Yeah, that's going to be a long answer. But we have some that are a combination of batch and online, which I'll be happy to discuss after. I think it's 11:31.
Thank you.